Example 2 starts off by asking to identify the values for where each radical is defined. So again, that's where things are possible or not, and then simplify. So again, what I did in the previous section, we looked at positive values, negative values, and 0 to help us figure out where things are defined. Here we have the square root of a. Can you plug in a positive number for a? Does that work? Yes. So positive numbers are good. What happens if you plug in a negative number for a? Negative numbers would cause you to take the square root of a negative. That's not possible. Can you take the square root of 0? Yes. So where this function is defined is when a is bigger than or equal to 0. Remember, the word defined is really asking where is it possible, and it's asking for the domain of the equation. What a values are possible. Now that we figured out it's defined, can we simplify this? They're already written as mixed radicals. Are they like radicals? Yes, because they're all square roots of a. So if I have 6 square roots of a plus 5 square roots of a, 11 square roots of a minus 11 square roots of a, all right, nothing left. So the question is, if you left that one blank on a test, should you get full marks? Yeah. Should try that. Just hand in your test completely blank. And then say, well, I thought all the answers were 0, so I didn't write anything. And then I hand it back to you and I said, it's already marked. Ooh. Part B. Where is it defined? Now, part B gets a little bit interesting because there's a values and there are b values. So we need to figure out when it's defined for our a values and our b values combined. So we have to analyze this a little bit. In each of those square roots, we have an a squared. What happens when you square a number, positive or negative? It's always positive. So one little note that we're going to make, that a squared is always positive. So if the a squared is always positive, what do we know about b? If we want to take a square root, will it matter if b is positive or negative? Because we need the whole thing to be positive, right? The 50 is positive. The a squared is always positive, so positive number times a positive number will still be positive. What do we need b to be? We need b to be positive. So our place, where is it defined? A can be anything. And b has to be bigger than or equal to 0. So we had to analyze the equation a little bit. Recognize that a squared means that it's always positive, and that in order for the whole thing to be positive inside, b had to be positive. Now simplifying, they're not like radicals right now. But can we simplify the number and can we simplify the variables? So square root of 50. Can you write the square root of 50 as two things where one of them is a perfect square? 25 and 2. Good. The variables. I can take the square root of a squared. Ooh, I'm running out of room. Here, I need to move all this over this way. Maybe make it a little smaller. Can you do that on your notes when you run out of room? Just grab it, move it to the left, shrink it a little bit. Yeah, it's called an eraser, I know. So there's the first part, and then we have minus square root of 8. Can you separate square root of 8 into two numbers? And we still have a squared and b, so I'll just write that again like 4 and 2. So some of you might feel like you're really good with your numbers, and you could go right to this next step. Okay? Square root of 25 is 5 root 2. I'm going to make a small mistake. See if you can figure out what it is afterwards. And this 2 root 2, and square root of a squared is a root b. It's a very tiny mistake, and it's really hard to see. Is the square root of 25 5? Is the square root of 2 2? Is the square root of a squared a? No. Close. Square root of a squared is? Absolute value of a. Sneaky. Is that sneaky? So I need absolute values there too. Because if a was negative 3, negative 3 squared would be positive 9, and then the square root of 9 is positive 3. So we add absolute value bars. So now when I put this together, I have, you can see that these are like terms. That all of the crazy stuff that we have is the same in both. So I have 5 of them here. 5 craziness minus 2 craziness. Right? That would leave me with 3 craziness. Are you okay if I write the absolute value of a first and then put my square roots back together? And we've simplified. One more to go, part C. We've got cube root of 27p cubed q. So first of all, you are going to love cube roots. Do you know why? You can take cube roots of positives and cube roots of, you can take cube roots of anything. So when it asks you when is it defined for a cube root, you're like, yay, it's everything. P can be anything. Q can be anything. So you're going to like cube roots that way. And then simplifying cube roots you're not going to like as much just because the numbers are bigger. Okay, in the first one, we have, here I'll rewrite it out, it was cube root of 27 p cubed q plus 8 cube root p cubed q. They are not like terms right now. This is one where I'm just going to go to the answer. Do I know the cube root of 27? Yes, it's 3. What is the cube root of p? Cubed. Just p, and I'm left with just a q. Plus 8, cube root of p will be p cube root, oh, that is not a good looking q, of q. Are they like radicals? And are they like terms? I have 3 p cube root q. Oh, say that really fast. P cube root q plus 8 p cube root q. Putting those together, you will have 11 p cube root q. That is almost a tongue twister. Here. Oh. Oh, we need Spanish yet. Tongue twister in Spanish. Okay. No, you can't figure those out. And do you know any tongue twisters in languages? Chinese? Do you know any tongue twisters? Okay, I'll let you look that up. Any other languages here? Yeah? In what language? Okay, Tagalog. Do you know what tongue twister is? So, look up tongue twisters. Any other ones? Peter Piper picked a peck of pickled peppers. So did you look at what tongue twisters is? Do you know any Chinese? No? All right. Unique New York, 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 unique New York. Oh, that one takes practice. Oh, wait. The only problem is now no one's doing any math. Should we just finish our last example? Okay. Well, there's questions for each question. That's what always happens. So these ones look easy enough, right?
No.
All right. Okay. Oh, we're still recording. Have we been recording tongue twisters?